Hi everyone. Today we'll be solving the question from Striver's SD sheet, that is merge sorted arrays and or merge two sorted arrays without extra space. So you can understand from the name that we are given already a sorted array and we have to merge both of the sorted arrays together. But what are the things we have to look for? The final sorted array should not be returned by the function. You cannot return, okay, anything in the function. Statement should not be written by you, basically that it means. And but instead of stored inside the array nums1, to accommodate this nums1 as the length, instead you store it inside nums1. Okay, so definitely we are going to have a void function, I guess. To accommodate this, nums1 has a length of m plus n. Okay, so nums1 have m plus n. It also have the extra space so that you can put nums2 here. Basically, nums2, nums1 have these zeros. These are zeros, actually doesn't represent any digit, because of course it says the array is given in sorted order, therefore 1 2 3 and rest of these three places are definitely kept for this nums2 which already have three elements. But of also the nums1 also have three elements. Now give pause the video and give a read to the question by yourself. Again, in example 3, it have zero elements. 1 0, that means there is a single element present in nums2, right? Therefore 1 will be here, output will be 1. So we have to return the final array after merging both the sorted array, right? And that sorted array have to be merged properly, right? Right, sorted. Sorry, I mean it should be sorted and merged, and we have to return it in array nums1. Also, extra spaces are also given nums1. So, what the initial thing that comes to your mind? Definitely, my thing was like, okay, I'll check both the elements in, one by one. Like, I will compare this element with this one and check whether this element is present here or not. Like that. I'll, sorry, not present here or not. Which one is greater? I'll, compare, like, one is greater than first element of nums2 or not. If it is, yeah, one is smaller, so I will put one nums1 at first, and again I will check with this one. 2 is of course equal, so I will put 2 and then again 2, and then I'll check 3 with 2. Okay, so since 2 is smaller, so I will put 2, and then 3, put 3, 5 and 6, like that. So that's the thing that comes initially, right? Or another thing also we can do is just, what else, you can just keep on thinking. One thing we can see that, we need to, you know two pointers or two iterations. We need something like, we need two pointers kind of thing, to point nums at nums1 and also to compare at something at nums2. So we need some two things, or you can say pointers, to keep track of elements in nums1 and nums2 respectively, right? So this is the thing that comes to your mind. Or we can just do one thing, that the brute force, like put all the elements of nums2 in nums I. Very simple. We'll keep a pointer here and keep a pointer here, and then we'll put all of this push here, right? Simple. The brute force. And then use the sort function and sort it. As simple as that, isn't it? Right? Isn't it? Because places are already given. We'll push all this nums2 element in nums1 and then finally sort it, right? That can be done. So that's the brute force you should say to your interviewers, right? So I is equals to m. Of course, it is m, right? And then j is starting from 0, because we are pushing all of this element here. So therefore, j is 0. So j is still less than is equals to n. It have how many numbers? It have a limitation, that is 3. And of course, I is less than is equals to m plus 1, because it have all total elements present in nums1 and nums2, therefore m plus n. And then nums I is equals to nums2. Why? Just, taking all the elements in nums I from nums j, and then, iterating I plus 1, j plus 1. I is also moving and j is also moving, and then just sorting it. Very simple. J is starting from 0, because we are pushing all of the elements from j to I, and I is of course is equals to m. while j is less than or equals to n, and I should be m plus n, because nums are 1 we have to return. Therefore j will be also increment in it, like increment as it pushes one element one by one. And then finally sort the function, sort nums1. So this was the brute force that came to your mind. Now we have to remove this sort, right? But with what is the time complexity for this? Definitely big of n log n, or you can say big of n plus m log n. That also you can say. And the space complexity? Tell me the space complexity for this in the comment section. Let's see how many of you get it properly. We're not storing anything. Yeah, again it's a void function. Check. Okay, so just a tip I gave anyway. And for the brute force, we have to remember, you have to remove this sort one, right? So for that, we just can, check the thing I have told initially that came into my mind. We can have 2 pointers, here one, and then keep on checking, using for loops. Definitely check which one is greater and then push it in nums1. As simple as that, right? So yeah. Not this. The optimal approach for this is this one. See, I'll start from the end of the I, because we are pushing it here. So I'm keeping a pointer at the end of the m-1 last element of nums1, and then same for j, keeping a pointer at the end of the nums2, and int k, taking another variable to keep track where I'll be taking the nums1. This will basically help nums1 to store the elements. Final combine nums1. This is combine nums1. Okay, so till j is of course less than or equals to 0, and of course also because we are running from the back side, ulta side, so it will be j is less than or equals to more than or equals to 0, and I should also be more than or equals to 0, and nums1 should be greater than nums2. Definitely if it is greater, then we will push nums k minus minus and nums1 minus minus. If nums1 I is greater, right, just think, if nums I is greater, then we will push this, and if nums I is not greater, then what? So here we have taken k as like the what's this? Okay, so here we have taken k, which is representing the both nums nums1. I don't know why I say nums I, sorry for that. And which is representing the complete nums1 and nums2. So I am using a two pointers approach here. So this nums first pointer I is here and this j is here. So 3, since 3 is not greater, therefore 6 will be coming here at the end of this, right? K is what? K is basically having 6 places. M plus n, that is 3 plus 3, which is 6, or if it is 0 based indexing, then 5 minus 1. Since it's a 0 based indexing, therefore I have taken k m plus n minus 1. So I think you are getting. So this will be pushed at the end of k, and j will be decremented, since here j is greater. So now j will come here. Since 5 is also greater than 3, so j will be decremented and it will be pushed in k. So 5 will come here. See, 5 came here. Again now 2 and 3. Since 3 is greater, so if statement will run now, and I will be decremented and I will come here. I pointer will come here and k will store 3. Now between 2 and 2, anything can pass. Definitely. So 2 will come again. For 2 again, it's 1 is left, so 1 will be coming and storing in k. So this is basically the simple, the most optimal approach for this question, and this is having a time complexity of big of n, and the space complexity is big of 1. We are not taking any extra space to store the answer. Just returning it in nums1. Just take in a k which have the combined elements of nums1 and nums2. I hope you got the answer. If you did, then please keep lead coding. Yeah, thank you so much for watching. Bye.